So in this video we'll talk about average atomic mass. Before we do though, you need to know what AMU is. So we've used AMU as a unit, but we haven't actually discussed what it is. So the AMU is exactly 1/12 the mass of a carbon-12 atom. So carbon-12 atom weighs 12 AMUs. You take 1/12 of that, that's 1 AMU. It seems kind of like a roundabout definition, but just go with it for now. And know this for the test. Now it's the standard mass value for atoms because grams are just way too small to measure individual atoms. Now we'll use the AMU for a little bit here. We'll actually kind of abandon it at the end of the chapter. We'll talk about moles and how moles are useful for converting AMU. Well, not converting AMUs to grams, but using the periodic table masses in grams instead of AMUs. So for now, AMU, 1/12 the mass of a carbon-12 atom, and let's move on. Now the average atomic mass, this is the mass that's found on the periodic table. So far what you've been using is called mass number, so don't get them confused. The mass number is equal to the protons plus the neutrons. That's for an individual atom. Now the average atomic mass is the weighted average of the masses of naturally occurring isotopes. So again, when you're using the mass number, you're looking at a single atom, a single isotope. However, when you're looking at the periodic table numbers, you'll notice that they have a lot of decimals in them. That's because it's the weighted average of all the carbon-12 and carbon-13 atoms that exist. So in nature, if you have a sample of carbon, a fraction of all the carbon atoms will be carbon-13, and the majority of them will be carbon-12. So the average mass of all the carbons in that sample is what you see on the periodic table. And it's, gosh, if I remember right, 12.001 AMU. Now, hint, use the sig figs for mass only, not for the percent occurrence. So you'll see what that means in the next slide here. So to calculate it, so we're going to practice calculating it. The first thing you do is assume you have a 100-gram sample. And what you'll be given the masses of both isotopes. So you'll get the mass of each isotope, and you'll get the percent occurrence. You'll see an example in a second. So just pause your video, write this formula down in the notes. And the thing you need to know is that you use, again, the sig figs from the mass. Ignore these sig figs. So what you do is you simply multiply the mass times the occurrence for each isotope. You'll get a number over here. So you get two different numbers. You add those numbers up. Once you add them up, you divide by 100. So we'll do an example here. Again, go back, pause the video if you need to write that down. So let's come up with the average atomic mass of silver. So again, you'll have your data. It'll look like this. So you got two naturally occurring isotopes of silver. Silver 107, silver 109. Now the very precise masses are right here. So you'll notice that the mass of silver 107 isn't exactly 107. That's because we cheated a little bit. The mass of a proton and the mass of a neutron aren't exactly 1. We just round up to 1, make your life easier. But use these masses here, the more precise masses. Now, the first step you do is you multiply the mass by the percent occurrence. That'll get you numbers, these numbers on the side here. Now, the second step is you add them together. When you add them together, you'll get this number if you type it into your calculator. Now, this is not your final answer. A common mistake that students make is they write this down as their final answer. The last step, because you're multiplying by percentages, you have to divide by 100. Now, some students will choose, instead to multiply by percentages, they'll convert these to their decimal forms. If you convert these numbers to their decimal forms and multiply, you would skip this last step. But because we didn't, you have to divide by 100. And you'll end up with this number. And you look at this number. This number lies somewhere between our two isotopes, which is good. And they're about 50-50 split, right? They both occur about equally. So we expect the mass to lie somewhere between these two numbers. And 107 does land pretty nicely between them, so I would accept this as a good answer, or a reasonable answer. because sometimes you might type it in your calculator wrong, you get an unreasonable answer. So always check to make sure it makes sense. The last step, if I count this number up here, has 1, 2, 3, 4, 5, 6, 7 sig figs. 1, 2, 3, 4, 5, 6, 7, 8, 9 for the bottom number. So I have to go by my lower number of sig figs. So I split it right there. I don't round up. And then I don't forget my units are AMU. So this would be my final answer. Again, watch this again if you need to. But what I want you to do as homework is complete this one on your own. Come to class and remind me that I have to do this on the board with you, and we'll see how you do. There is one more step to this problem, though, is I don't tell you what element this is. So you got to identify what element we're working with. So what you're going to do is multiply, do your work, come up with your answer. Whatever answer you end up getting, compare that to your periodic table. It should match one of the masses on the periodic table. That's how you'll identify which element it is.